I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. Let me thank all the subscribers and viewers for watching my videos and posting excellent comments. In this video, we are going to discuss a very important question based on conditional probability. I would like you to pause the video, read the question properly, answer, and then look into my suggestions. Here is a very important question based on conditional probability. We'll use two-way table to solve the question. Example here is there are 80 students in grade 12 of Global Math Institute. 35 students of these study only maths M and 25 study only science S. 12 study both maths and science. Draw a two-way table to show this information. Find probability of not studying math intersection not studying science. C. Find the probability of studying maths when already science is the subject taken. D. Find the probability of students who are studying science but they are not studying maths. It's a conditional probability. That means we have to find the probability of students who are studying science out of, or it is given that they are not studying maths. You get the idea. So that is the conditional probability question. I'd like you to pause the video, answer this particular question, and then look into my suggestions. Now let's try to understand the concept of conditional probability before really getting into this solution. So, conditional probability means that if something has occurred, then the next event's probability might change depending on what has occurred already. So that is where the conditional probability comes into picture. We can say that if the probability of an event can change depending on the outcomes of previous event, then the concept of conditional probability be used to solve situations. A vertical bar is used to represent the conditional probability. So we say probability of finding probability of B event happening when it is known that A has occurred. You should read this as probability that B occurs given that A has already occurred. Correct? Now, if the events are independent, then what happens? If the events are independent, then the probability will not change. That is to say, probability of B when A has occurred will be same as probability of A when B has occurred, and it will be equal to product of the probability of A with probability of B. As I was saying, you could solve many questions based on conditional probability using restricted sample space. So we'll use this principle here also. So conditional probability situations can be solved by restricting the sample space of the outcome to the event that has already occurred. Keeping this in mind, now let's try to solve the question given to us. So the, there are 80 students in grade 12 of Global Math Institute. 35 students of these study only maths and 25 study only science. 12 study both maths and science. Draw a two-way table to show the information. So two-way table involves rows and columns. You see that? So I'm just making this two-way table. What are we given? We are given the condition that the students are studying two subjects and these two subjects are maths and science. So a student may study maths or may not study maths. You get the idea. Complement. Similarly, the student may take science or may not take science. The complement of that. You see that. So we have two columns, and these columns can help us solve conditional probability questions. Now, whenever we have these columns, we have to always add another column which will give us the total, right? So I'm extending this as being shown here. And we are going to write here total number, right? So let me write total. So that becomes the total number of outcomes when we are solving questions based on probability. Perfect. So first thing first, there are 80 students, right? So 80 students in all. So that goes in here. So we can write down that there are 80 students. Clear? 35 students of these study only maths. Only maths means not science, right? So when I say only maths, it means what? Only maths. 35 students study only maths means maths but not science. So that is where I am going to put this number 35. 25 study only science. So only science means science but not maths, right? Clear? So that is given to us as 25. 12 study both maths and science. So both maths and science is this column, correct? And the number given to us is 12. So that is the information given to us. Now, how do we work with this information? Well, first thing, you have to find all the totals, right? So add them up and write down the totals. So, if you go with science students, so total students of science which have taken maths or not taken maths will be how many? So 25 plus 12. So 5 plus 2 is 7 and 2 plus 1 is 3. So that gives me 37. We can also total this lot, which is 12 plus 35, and 5 plus 2 is 7, and that is 4, 47. Now we know that total is 80, so we can fill up the other columns. You get it, right? So if I do 80 minus 37 in the total, what do I get? So if I do 80 minus 37, in that case, I get 43. So now I can write down this number as 43, which is 80 minus 37, correct? Similarly, I can write down the number here, which is 80 minus 47. So all the missing numbers in our two-way table can be filled in. So if I have 33 here, then 33 minus 25 gives me the number in this blank space. So all these numbers can be easily calculated from the given information. Is that clear to you? So given information is shown you with highlighted items and the calculated ones is shown not highlighted as given here. Correct? So we have now a two-way table. So that is what we mean. Draw a two-way table to show this information. So I hope this is absolutely clear, right? So that is how you draw a two-way table for the given information. Now you can see it will be very simple to answer the conditional probability questions from here. Now let us figure out the solutions. So here is the two-way table for your convenience, the one which we had just drawn with all the numbers which were given and which we calculated. Now, question part B is find probability of students not taking maths, intersection, not taking science. So, from the total students, right? So, here we are looking into total students are 80. So, the outcome here is 80. Now, out of this 80, we are looking into the intersection of not maths and not science. That is to say, this is not maths, do you see that? And this is not science. So the intersection is what? So the intersection clearly is 8. So 8 comes on the top, and we could write this as 1 over 10. So the intersection of not maths, not science is as shown here, highlighted as 8, total number of students being 80. Therefore, the probability is 1 over 10. Is that clear to you? Perfect. Now let's move on and find the solution for part C. So we're done B now. Let me erase this and get to the situation. Now, we need to figure out what is the probability of a student taking math, but we know that the student has already taken science, right? So that means we are again looking into restricted domain. So in the condition given to us, we are looking into all those who have already taken science. So we are looking into this group of students who have already taken science. Do you see that? So that is the highlighted group which we are now interested in. And says, out of this, how many have taken maths? You understand now? So maths, how many have taken? 12. And therefore, the probability will be 12 over 37. Is that clear to you? So that is how we are going to get the solution. Clear? I would like you to answer the next one on your own and then watch my solution. Now, this time, what are we looking into? We want to find the probability of students who have taken science and we know that they have not taken maths. So, when we say that they have not taken maths, then what should I highlight? Well, clearly, not maths is this group, correct? And what are we interested in? We are interested in the outcomes of students who have taken science. So this is the group which has taken science but not maths, correct? So 25 out of 33. You get the idea. So that is how very easily these conditional probability questions can be solved using two-way tables, correct? So I hope the concept is absolutely clear. Feel free to write your comments, share your views. In case you have any difficulties, do not hesitate to contact me on the email address given here. You can also go to our website and check the latest videos. I hope you find it useful. Thanks for your time and all the best.